Okay, hi everybody, welcome back. I'm gonna go ahead and go through the number 1 on your homework today. I included these steps, numbers 1, 2, and 3, to kind of help you guide yourself to in which order you should be looking at these graphs and how to then translate this into a factored form. So with number 1, it asks us to just find those x-intercepts and then put those into the parentheses. Number 2 is looking at the degree, so therefore the multiplicity, how it's interacting with that x-axis. And then number 3, it's asking you to check to see if it should be a negative or positive coefficient, which we will talk about here in a second. Okay, oops, let me go back in. All right, let's look at this first example. So let me take a screenshot really quickly, just so I can write on this. So I'm gonna zoom into this graph really quick. We have these 3 x-intercepts. This first x-intercept is at -3. The second x-intercept is at 0. And my third is at +2. Remember that if I were to put these into parentheses, I have to switch the sign, meaning positive and negatives, except for the 0. The 0 part doesn't super matter, but we'll keep going as explained. So for the -3, if I put this into a parenthesis, this is going to turn into x plus 3. Then for the 0, I can just make this easy and go x minus 0. It means the same thing. You could also do x plus 0. It won't change much. And then for the +2, I would put this as x minus 2. Okay, now from here, I need to look at my multiplicity. The multiplicity is how your graph is going through, bouncing off of, or interacting in general with your x-axis. So if I look at this first x-intercept right here, it's going directly straight through my x-intercept, meaning that this multiplicity is 1. Which therefore means that I'm just going to keep this exponent here as 1, and it can just stay right there as x plus 3. For the middle x-intercept, we're seeing this parabolic relationship that it's bouncing off of this x-axis like a quadratic. When that happens, this is where your multiplicity would be 2. When your multiplicity is 2, on that root, in your factored form, you would put an exponent of 2 where that x-intercept is. Okay. And then lastly, where x-axis hits the intercept of 2, it's a straight line again. So again, this multiplicity right here would be 1, just like it was for our x-intercept of -3. So now I'm going to go up, and that equation there is still going to have an exponent of 1 there for my x-intercept of +2. Okay, I'm going to go ahead and hopefully by memory type all of this into my Desmos activity here. Remember that you don't really need to include these 1 exponents, the exponents of 1, sorry. You don't really need to include those. It's not overly necessary. It's the same thing as if you were to type in x plus 3, x minus 0 to the second power, and x minus 2. Now, some of you might recognize that x minus 0 is just x, and you would be correct. I could transition that into x squared, and we've seen problems like this before. However, when we saw them in class, they looked like this. They looked like x squared, parentheses, x plus 3, and parentheses x minus 2. So in the problems that we did during class, these x minus 0 roots, those were just stuck in the front because that 0 ended up canceling out. Does this really matter in this case? Not at all. Not at all. You can 100% keep it. You can 100% keep it as what I have right here. You can 1000% keep it like this. And that is A-okay. All right, I'm going to go ahead and take that, and I'll put that into my Desmos. Give me 1 second. Let's see, pause, delete screenshot. Okay, I've got x plus 3 close parentheses, open parentheses, x minus 0. That is a multiplicity of 2, so I'm going to push the a squared button. Okay, and then I have parentheses x minus 2. All right, from here, my graph is the red one. The graph I need to match it to is the green one. And what I'm recognizing is I'm recognizing this reflection over the x-axis. When that's happening, that means I'm so close, but my graph should be negative. Okay. So I'm going to go into the front of this graph, and I'm going to put a negative symbol. And all of a sudden, now my graph is orientated correctly. Okay. So again, if that happens to you where it looks like you've got everything right, but it's just oddly reflected, if you put that negative symbol in front of it, it should match up. Again, let me show that one more time. Without the negative symbol, it looks like this. With the negative symbol, I am matched up perfectly. Okay. Now, where am I seeing all of these pieces? Let's look at this one more time, just in case you need this extra help. So in each of these roots, like numbers, the positive 3, remember that if I were to have gone backwards like we did during class, this would have switched to a negative 3. That one would just be 0, and this one would just be a positive 2 from each of those. Okay, so from those values, I am getting my x-intercepts, which I see right here on your graph. Okay. Then from here, I need to look at the multiplicity. Again, I'm just going over the pieces of this problem. You could totally stop the video here if you understand from here on out. But if you're still a little confused, I'm just going over which pieces come from what. This multiplicity of 2 right here is coming from the fact that through this x-intercept at 0, our graph is bouncing. Let me make that one a little better. Is bouncing off of the x-axis rather than going through it directly like our other x-intercepts. So remember, if it's going directly through it, this would be where your multiplicity is 1. If it is bouncing off of it like that, this is going m equals 2, that multiplicity, and from here this would be m equals 1. Oops. Now just keep in mind that in other problems, if you start to see a graph look something like this, this would be an example of where your multiplicity would be 3. So in that type of behavior, this is where your m would equal 3. But for us in this problem, we're not having to worry about that right now. Okay. So connecting those back, that is why in my equations over here, only one of them needed the exponent, just the x minus 0. That one had the multiplicity of 2, but these ones were technically just a multiplicity of 1, which those are just those invisible exponents. I ended up having to make my leading coefficient negative, and the reason for that is because when I looked at my graph originally, my ending arrows are technically pointed downwards. If I were to have drawn my ending arrows, my right arrow and my left arrow are both facing negative infinity. Okay. The main one that you would really care about would be this one. That arrow is going to tell you whether or not it's positive or negative. But in this case, since we are an even degree, both arrows point in the same direction. Okay. I hope this helped, and if you have any other questions, feel free to reach out to me, and I will see you guys in class tomorrow.